Okay. Yes. Definition 1. Calculus. Let's go back to the beginning. There's a big problem in calculus that we try to discover an answer to. Do you remember what that question is? How do we find the close slope of a line that is tangent to a curve? We don't have time today, but I will get to the point of this, okay? We don't have time today, but I'll get to the point of this, okay? So, so I have this coordinate here, and we said that you can't find slope at a single point, can you? Can't find slope at a single point. Everybody agreed? Okay. So I have point A right there, okay? How do you come up with the y value? You plug it into the function, and when you plug A into the function, you get f of A. What we would like to do is find the slope of a line that is tangent to the curve at that given spot. Okay, that's what we'd like to try to find. All right? So what we've decided is we can't find the slope at one point, so we create a second point. I'm going to call that x. I plug that into the function. What is the y value? F of x. So what you've told me is in order to find slope, we do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. What is y sub 2 in this scenario? F of x. This is the function, this is the output. It's the same thing. Minus f of a all over x minus a. So we've already looked at that at the beginning. The deal is right now, if you look at the slope of that line, how does that compare to the slope of the tangent line? Is it greater or less than? Definitely greater than the red, right? Okay, that's steeper than the red. Everybody agreed? I would like these to become the same. What could I do to come up with a more accurate estimation of the red slope? What would I do to this point? Bring it closer to here, right? So that means that x moves closer to A. How do we say that mathematically? That's the whole point of everything that we just did. We say the limit as x approaches A of that is equal to the slope. We now have a formalized definition of the instantaneous rate of change, or the slope of a line tangent to a curve at a given point. You already know how to do this. We are defining a way for you to understand. Now, some of you will look at this and you start to file. You have that delete spot in your memory, like the trash cans. Like, I could just throw that there. I never need to know that again, right? I can't encourage you guys enough. Every single picture that we write down, it is useful for your time moving forward. That picture is one you should understand. In fact, when I first started teaching the class, and up until just a few years ago, everybody would have to draw the picture accurately on the first test and explain what it meant in words accurately. Okay? So not having to do that this time, things have changed a little bit since COVID, but I'll probably go back to that some given time. But this is extremely important that you understand what the heck that means. That is the calculus. Let's try a couple problems, and you can see how it works. Find an equation for a line tangent to the given point using definition 1. What I've just given you is definition 1. Limit as x approaches a of f of x minus f of a all over x minus a. So what I would like to do is I would like to find the slope of the line tangent to x squared minus 3 at the point 1, negative 2. So I just do that. The limit as x goes, let's do that. Limit as x goes to a. What is the value you're approaching? What is the x value we're getting close to? 1. Function. What's the function? X squared minus 3. Minus, what is f of a? What do you get if you plug 1 in? Everybody see you get negative 2? F of a is the y value. That's what you get when you plug 1 in. Watch. If I plug 1 in, I get 1 squared is 1, minus 3 is negative 2. So we've provided it for you. Okay. Divided by x minus what? 1. A is the x value that you're approaching. And so I get the limit as x goes to 1 of what? What's in the top? X squared minus 1 over x minus 1. Have we learned how to deal with those limits? Yes, I've taught you how to deal with those limits. That's equal to the limit as x goes to 1 of x minus 1 times x plus 1 all over x minus 1. What happens? Cancel them. Everybody pause. Look originally. If I would plug 1 in, what would you get in the top? 0. What would you get in the bottom? Every single time you do this, you should come out with 0 over 0. And so in calculus, we're discovering that value of 0 over 0. In this case, 0 over 0 ends up being 2. So that tells us the slope is 2. It says find the equation for the line. So I have slope. What else do I need? My point on my line. Do I have my point? What is it? 1, negative 2. Could I now write an equation for a line? Y minus what? Y plus 2 is equal to? So I have y plus 2 is equal to 2x minus 2. Or y is equal to 2x minus 4. In order to save time and allow you guys time to work today in class, I will not write all the equations of the lines for you because you know how to do that, don't you? But that's how you check your answer on the test. Sometimes people ask me, we'll go to your question in a second, sometimes people ask me, say, Mr. Gens, do we have to write the equation for the line on the test? And my response is, why wouldn't you? Isn't that how you check your answers to see if they're right? What was my function? X squared minus 3? And what's the equation for the tangent line? 2x minus 4. So sometimes people say, why are you making us write the equation for the tangent line? I'm like, I'm trying to help you out. I'm trying to show you whether or not your answer is correct. Is my answer correct? Heck yeah, I verified. I'm an excellent mathematician. Question.
Why did we figure out the limit? Like what did we use? We have to use that figuring out the point.
So this gave us the slope.
Oh, that?
Yeah.
But isn't the slope x plus 1?
The slope is equal to that.
So you would graph x plus 1. I literally don't know.
Let's try again, see if it comes up again for you, okay?
You know the equation for Rotem current? Yeah. That's the whole thing is that. Yeah.
Okay. Okay. But erase whatever happened in the brain. Let's try together, okay? I need to write an equation for line. What two things do you need? Slope and a point on the line. What is the point on the line? 223. I got to find slope. How do we find slope? It says you take the limit as x approaches. Sydney, what is x approaching?
2.
2. Of what is the function? 3x cubed minus 1 minus what is f of a? If you were to plug 2 in, what do you get? If I don't, on your worksheet, I don't give you 23. So how would you come up with 23? You plug 2 in and you get 2 cubed is 24, or 2 cubed is 8, times 3 is 24, minus 1 is 23. All over, x minus, what did you say a was? It was 2. So I have to determine that in order to get the slope. So I get the limit as x goes to 2 of 3x cubed minus 24 over x minus 2. I plug in 2. I get 0 over 0. Is that a problem for us? Not for us. Like, it's a problem that we got to figure out, but are we going to be able to work through this? Can anybody else outside of this classroom in this school work through that? There might be a couple, but let's figure it out. Limit as x goes to 2 of, what do you factor out? 3 times x cubed minus 8 over x minus 2. Can I factor x cubed minus 8? Yeah, sum and difference of cubes. What if you didn't remember that? What did I teach you yesterday you could do? Synthetic division. Limit as x goes to 2 of 3 times what? X minus 2. Good, you got the binomial. How do I get the trinomial? X squared, what goes on the end? Plus 4, what goes in the middle? 2x, is it plus or minus? Very good, it's plus. It's opposite the sign there. Go ahead.
So the last one you square the 2?
Square the front, square the back. So square x and square 2, that's your front and back. Multiply the 2 together for the middle, and then this sign is opposite that sign. That's always positive. Got it? Okay, what happens? X minus 2's are gone. Can I plug in 2 now? Yeah, 2 squared is plus 4, times 3. Slope is 36. Could you write your equation for your line then? You sure could. Letter D, please just set up the limit on your own. Please take 30 seconds and set up the limit on your own. D, skip C. To letter D, set up the limit on your own. And pause. Is that what everybody got? Sorry, it's a plus 2. Everybody got that? Okay. Now, x cubed plus x plus 2, that doesn't look like something I know how to factor. So therefore, I have to use synthetic division. Fortunately for us, it's no big deal. Okay, what number do I put in the corner? -1. Because that's the value that's the solution to x plus 1. What numbers go across the top?
1, 0. Yeah, right.
Tim, you have a question. What's your question? Okay, so the rule is f of x minus f of a. Tim, what's f of x? Minus f of a is -2. We good? Let's divide. That's my remainder. Remainder should be 0. How do I start? Bring the 1 down, then, and get? What do I do next? Add 1. Add to get 2. So it looks like we have x squared minus x plus 2. Is that accurate? So we have the slope is equal to the limit as x goes to negative 1 of. We divided that out and we got this. X squared minus x plus 2. Can I now plug in negative 1? Yeah. What's negative 1 squared? 1. Minus negative 1? So plus 1 is 2. Plus 2 is 4. Slope is 4. What's the question? Okay, all right, so I didn't write it out. I'll show you one more time. This thing up here, we actually learned that it factored. Limit as x goes to negative 1 of x plus 1 times x squared minus x plus 2 all over x plus 1. We learned the top does factor, factors to that. And we canceled that off, so we're just left with that. That's what happened to it. Better, Jack? Yeah. Okay, so those are 2 examples of polynomials. You should be able to handle an x squared and an x cubed on your test. Could you do that? Okay, the other 2 you'd have to be prepared for, these 2 you see here. Okay, so can you handle a radical? Slope is equal to the limit as x goes to what? 6 of what goes next? Good. Square root of x minus 2 minus 2 over x minus 6. Great. I don't see any factoring here. Who's got the bright idea?
Multiply everything by x. Square root of x minus 2.
Good. Yep. Spanish. Let's go. Conjugate. Square root of x minus 2 plus 2 over square root of x minus 2 plus 2. We multiply by the conjugate. Through that. Slay. No. No, after a while it's like, M? Are you kidding me? All right. Square root of x. Square root of x minus 2 times square root of x minus 2. X minus 2. What happens to the middles? And then at the end you have negative 2 times positive 2. Negative 4. All over what? X minus 6 times then that quantity. Square root of x minus 2 plus 2. Pause and look at it. What do you notice? It's going to be x minus 6 on top, isn't it? So it's going to, yeah, so what are you left with in the top? Just 1. Can I now plug in 6?
Yeah.
What is 6 minus 2? Square root? Plus 2? So what do you get?
1/4.
You should be able, on your test, you should be able to handle a radical. The last one we want you to be able to handle is a rational expression. And that's it. Then you guys can have time to work and ask questions. Slope is equal to limit as x goes to what? 3 of what?
1 over x.
1 over x minus 1 minus a half. All over?
X minus 3.
Yeah. It's interesting again, and so still from a math teacher's perspective, 14 classes beyond calculus, I still just love when I look at this. When you plug in the 3, you get 1/2 minus a half, so you get 0 on the top, you get 0 on the bottom. It's still the same. It's always 0 over 0. And how do we figure that out? Well, anytime you get 0 over 0, there's this way of factoring or something that's going to make everything come through to where you get an actual value or an answer. It's really quite amazing how it works out so beautifully every time. Complex fractions. You did them last year. I walked you through section 1.4. College algebra is just working through them right now. How do I handle that? Common denominators. Actually, I gave you the speech. I told you last year if you can't figure out how to do complex fractions, you shouldn't take calculus. But fortunately, you were all able to figure out complex fractions. So you multiply the top and bottom by 2. And we multiply the top and bottom by? Good. There was a little bit of reality check. Some people were like, no, I never actually did figure it out. Here's your second chance to figure it out. We see it again. Hi.
Wait. Hello. 2 over 2 for the left?
Yeah, I'm going 2 over 2. So I have the limit as x goes to 3 of, what's here? 2 minus, what am I going to have here? X minus 1, so it'd be a minus x plus 1. That's a mistake you make. I distributed the negative sign to the x and to the negative 1. Abe's, we good? Yeah, it kind of looks like a 3, doesn't it? Sorry about that. Over, what's the denominator? 2 times x minus 1 over x minus 3. So we're almost done with this guy, and we can trust that, like we said, 0 over 0, it always works out for us. Limit as x goes to 3 of, what's in the top? 3 minus x. Over 2 times x minus 1. And then instead of dividing by x minus 3, how about I multiply by the reciprocal? Yeah. Multiply by 1 over x minus 3. Can I just cancel off the 3 minus x and the x minus 3? What do I have to factor out? So I factor out a negative 1, and now I can cancel them. I'll write it out. If I were to factor out a negative 1 out of 3 minus x, it becomes positive x and becomes minus 3. So I'm taking that and then canceling it out. You see that? I took the negative and paired it over, and then they're gone. No? I'll write it out again if you need to. All right, so now can I plug in 3? 3 minus 1? 2 times 2? 4. Negative 1/4. Now, I'm Avery. I'm sitting on the test. I'm like, shoot, I've only got about like a minute and a half left. I don't know if I have time to write that equation for the line and check my answer. I would like to see if I have a reasonable answer, at least reasonable. So what I'm going to do is I'm going to graph that function. What does that function look like?
It looks like
Yeah, shifted to the... Yeah, thank you. Do you guys understand why I took you through the review I did? I'm not trying to make life harder. I'm trying to show you the things that are going to help you moving forward. So I'm going for an x value of 3. So if Avery comes up with an answer of negative 1/4, she just thinks about that function. Does it look like that's reasonable, that negative 1/4 could be an option? You see how she knows that it's for sure negative? Yeah, I mean, maybe it's negative 1/5, but at least she knows she's in the ballpark. Get my point? You guys got it. Your time to work. Go.